We're going to study about the four characteristics of PN junction. First of all, we're going to study about the forward bias and reverse bias. So we already know about the P and N junction here. Like if you're going to make a PN junction, so here is the P and here is the N, and P is penta and N is tetra. So it will have more holes. So it will be a majority hole carrier and less electrons. And here will be more electrons and less, very less holes actually. So here will be more holes and here will be less electrons, but here will be more electrons and less holes. And here will be full positive ions layer, and here will be negative ions layer. And we already know why is it due to. So each full region is known as the region of resistivity, or where there is junction actually. So this hole is a junction due to ions, positive and negative ions, because now we're gonna attach it with a DC current, like current is there. We're gonna attach the P with positive terminal and N with the negative terminal. And now what is gonna happen in forward bias, that you're gonna see electrons in here and it's negative. So electron will go and attracted with the positive ones, and they will go and flow from here's hole, and the current will be generated then, because electron flow will be theirs then. But they needs to pass from this junction. So when there will be 1 volt of current, so they are still trying to pass through the junction in 2 volt to 3 volt, like 0.2, 0.4 on the graph. Like the starting values of them is like for just passing from the junction, because they need more voltage. And then when they are gonna flow, so there will be the thing that they are now passing and the current is generating. Okay, so uh, and if we want to study about them on a graph, or like if we're gonna study them on a real stuff, so we're gonna make a resistance here and we're gonna attach it with a variable source of current, and then we're gonna make it here junction, like P and N junction. Like we're gonna study, here's a positive and here's a negative one, and here's you're gonna make ammeters here, and here is a voltmeter for reading the values of current and voltage actually. So there is a variable source actually, so variable current is there. So we're gonna study about them on a graph. Like let's make a graph. Like this is a graph for current and this is a graph for voltage, and let's make the values like current values be there like 20, like 40, like 60, and then 80. And then here will be the voltage, which is when 0.2, when 0.4, when 0.6, when 0.8. So when we're gonna increase voltage firstly in initial, so they're just getting more kinetic energy to pass through the junction. So still the current is voltage is increasing, but the current is like zero actually. This is the current, so this is zero. So when it's 0.2, it's still zero. It's still zero, but when it's gonna be 0.7, so it will increase, because silicon has a value of 0.7 when they will pass through the junction. Actually, they will got a kinetic energy of 0.7 volts, so they can actually pass from it. So this is the thing about the silicon. So the electron will now flow and then come here's full there's, and then voltage is already there, potential difference in there, so they will keep on flowing. So this is how the value of this is increasing. And now if we're going to study about the reverse bias. So what is reverse bias actually? Let me see it too. In reverse bias, we are going to attach the P with the negative and N with the positive terminal. So you can see the positives are, the holes are actually positive, so they will be attracted toward the negative ones, and the electrons are negative, so they will be attracted to this one. But you know that in P there are some electrons, so electron will be attracted with the positive ions. Okay, as you know, the like these are gonna attach with the negative one, so there's to leave more positive. There's more positive ones will be there because they're leaving their places, and in the negative ones when they are gonna attach with this positive, so more negative will be there. It means there's some negative here, the minority one is there, so they are gonna have kinetic energy to be attracted with the positive and to leave the junction from here, so they will keep on flowing electrons and they will cause some of the kinetic energy they will have, and then they will flow the current in this way. But there is a thing, there is like if they're gonna use it, like if they're being attached to the negative one, so there are so many electrons are now being evolutionized that there are so many positive ions will be there. This is known as avalanche effect. Avalanche means a very big thunderstorm of electrons will be there. Yeah, if we're gonna study about in reverse, so we're gonna say what is Zener effect. In reverse, we ask if voltage is increased, like if voltage is being increased due to available energy, covalent bonds are being uh, covalent bond, because p-n junction is made of silicon actually, so the covalent bond of these electrons are gonna break and there will be a huge buster of the electrons there only because the covalent bonds are already break up. So that is an avalanche effect. So in reverse bias, as we know, both are positive, so they will be attracted to negative, and here the negative will be attractive towards the positive, and so many ions will be there. So this junction is actually being bigger and resistivity actually increasing. So how we can make the graph of I and V actually. So if it's I and it's V, so how we gonna make about it? So in reverse, it's reverse. We're gonna use the reverse x-axis and this current. So we're gonna make it here voltage, and we're gonna make it here current. If the value of I is like 10, we can get say 10, and its value of 20, and it's like 30, and here it will be 20, 40, 60, and 80. So if we're gonna increase the voltage firstly, so there will be no effect because still they are being attached, and the kinetic energy of these electrons is being there, so they will go from the junction and pass on to create a current. But when it will be there is for on the some instance, like if it's on the 70, so the current will start flowing. Okay, so here the current is being caused by the minority elements and p junction due to flow of electrons, but in the forward bias that was due to the majority and the n bonds. So this is our topic about the avalanche effect, Zener effects for characteristic of p junction, forward and reverse junction. Forward and reverse. Uh, so if reverse bias, if voltage is increased due to available energy, covalent bond breaks. The covalent bond being break and a large number of electrons will release. This sudden increase in current is called Zener effect. And if reverse bias is increased further, if more energy is being there, so there will be more blunder of electrons. So they will gain more velocity and more electron. Covalent bond gonna break, so that's avalanche effects. So during these effects, Zener diodes are formed. So these things Zener is gonna be formed. So this is whole about this reverse forward and Zener and avalanche we studied today. Thank you.